right, hey y'all, it's Mr. Kyle with Myers Mathematics, and let's just jump into it. We're going to work out a few problems on indefinite integrals using trig subs. And I think we've got a mix of everything here. So we'll have at least one of each different kind of trig sub, so you can see how they work. So we'll start with number 5, and I'll kind of try to color code these as well, so that even though the work might end up being a little close together, hopefully it won't be too close. So we'll start with that. And the way I like to remember these is if you have the non-x term first, then it's a squared minus x squared is a sine theta equals x. And for us, the way I like to remember this is a sounds like bay and x sounds like x. So if your bay is before your x, that's a good sign. So then that helps. And a is going to be 3. Our x term is actually going to end up being 4x squared, because if I square that, if I times 4x squared by itself, I would get 16x to the 4th. So that's actually going to be my a and my x. So it's going to be 3 sine theta is equal to 4x squared. And then I can take the derivative. There's actually a lot of things you can do with trig subs. You can square them. This one's kind of optional, but I'll show you how it's helpful, because this turns into this. And then when I go to plug that in over here, that's going to end up being 9 square root minus, and then 16x to the 4th is equal to 9 sine squared of theta. 9 sine squared theta. So it's helpful to square it, but then we also want to take the derivative. So taking the derivative would look like this. 3 cosine theta equals 16x dx. Oh, hold on. Nope, 8x dx. I was like, hold on, that didn't sound right. I was looking at the previous line. So I'm taking the derivative of 4x squared with respect to x, and that's going to be 8x dx. And that's actually already equal to this right here. So sometimes you can just solve for dx, and that is the simplest way to do it, and that's always a good idea, especially if you're not sure, if you just want to be really careful. Solving for dx is kind of like the way to play it safe, I guess, so to speak. But that's exactly what that is, so I can actually just replace that with 3 cosine theta d theta. And I forgot to put a d theta on there. There'd be a d theta. I'll just stick it in right there. D theta. So it would be 3 cosine theta d theta. Normally you'd put it on the back end, but I just forgot to put it, so after the fact. And then we can go ahead and take the integral at that point. The other thing you can do with the derivative is you can solve for theta. So if I were to take 3 sine theta equals to 4x squared and divide by 3, I would get sine theta equals 4x squared over 3. And then if I take the inverse sine of both sides, then I would end up with the sine inverse of 4x squared over 3 is equal to theta. So when I go to plug all this in, and I'm starting to run out of space, so what I'll probably actually end up doing is for numbers 6, 7, and 8, I'll start showing less steps so that I can fit it all in here. Or I might just kind of move the board a little bit as we go. We'll see. So basically, we're going to come down here. So this is going to be the integral of 3 cosine theta d theta over, and then that's going to be, if I factor out a 9, it would be 1 minus the sine squared of theta. And then that, so I will have to probably move this. I'm going to go up this way. How far can I go? Oh, pretty far. Okay. So then what we're going to do here is we're going to, actually I'm going to go ahead and put this d theta out here. I think it's going to look better over there. And then the square root of 9 is just 3. And then I have the square root of 1 minus sine squared theta. And 1 minus sine squared theta is equal to cosine squared theta. These 3's are going to cancel. And actually so with the cosines, because the square root of cosine squared theta is just cosine. So I actually end up just taking the integral of like 1, right? It's the integral of just with respect to theta, like 1 d theta. So that's just going to end up being theta. And theta is the sine inverse of 4x squared over 3. Don't forget to add a constant for that final answer because it's indefinite. And if it's definite, don't forget to plug in the limits of integration. So there's both of those things. And that's actually it for number 5. So there you have it. And let's see. Probably do number 6 off to the side a little bit. Let's flip over to here. Yeah, I think that's where we'll do it. Okay. So we're going to switch to a different primary color. Add a little bit of orange to it so it's a little easier to see. And this one's actually going to be pretty much the same thing, except it's going to be a different trig sub. This is in the form x squared minus a squared, which is a secant theta equals x. Awesome, you guys can still see that. Okay. And the way I remember this one is it's the reverse of sine. Sine was if your bay is before your x, that's a good sign. This one is if your x is before your bay, you can't see. So our x term is actually going to be x cubed, because x cubed squared would be x cubed times x cubed, which is x to the 6th power. And then a is actually just going to be 1. So this is going to end up being just 1. So secant theta, 1 times secant theta, equals x cubed. And I'm not going to square this one. Instead, I'll just write it out as I go to plug it in. But we will want to take the derivative. So the derivative of secant is secant tangent. Derivative of secant is secant tangent. And then the derivative of x cubed is 3x squared. So there you have it. And that's literally this again. So that whole part right there turns into secant theta tangent theta d theta. And on the bottom, I have another x term. I actually have an x cubed. X cubed is equal to secant theta. That's my sub, so I'm going to sub that out. And then inside the radical, that's going to be x to the 6th, which is x cubed squared, or secant squared. So this is secant squared minus 1. Okay. So then that's going to end up being, and I can go ahead and cancel those secants right now, secant theta, oh, I canceled the secant theta, JK LOL, tangent theta, d theta, and then the square root of secant squared minus 1. Secant squared minus 1 is equal to tangent squared. That's one of your Pythagorean triples. Pretty much all of these use Pythagorean triples. I mean, I don't know if I've ever seen a trig sub that didn't use a Pythagorean triple. So you want to know, or not one of your Pythagorean triples, sorry. One of your Pythagorean trigonometric identities, I should say, which are sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and 1 plus cotangent squared is equal to cosecant squared. So those are the big 3, and you actually only use 2 of the 3. But anyways, so this is going to end up being really, really similar to number 5 in that the square root of tangent squared is just tangent, so that ends up just being the integral of 1 with respect to theta, which is just theta. And if we solve for theta again, it would be taking the secant inverse of both sides of this, which would end up being the inverse secant of x cubed. Inverse secant x cubed plus a constant. Okay, so that is it for number 6. We're gonna flip on over here, and I think I'll put it right about here so that way I can do all the work to the left-hand side of this one. All right, and let's flip to maybe a nice deep shade of red here for number 7. All right, so now then, what we would do with this is the same as before, and this is actually going to end up being the third of the 3. We've done a sine trig sub, we've done a secant trig sub, And this one is plus. Plus looks like a t, so it's the tangent. So I don't have a clever saying for that one. Just plus looks like a t, so this one's not as exciting as the other ones. So plus looks like a t. This is tangent a, tan theta equals x. Our a term is going to be 4, because 4 squared is 16. And then our x term looks like it's going to be 5x squared, because 5x squared would be 25x to the 4th. So then that's going to be a tan theta is equal to x, or our x term. Sometimes you guys will use u. A lot of books will use u and just say that it's u squared and u is a function of x. But I like to just call it x, because sometimes it is literally just x squared. So anyways, we're going to take the derivative of this. So then that would be 4 secant squared theta d theta. And then the derivative of this would be 10x dx. So look at that. It happened again. 10x dx is literally the same thing. So it's going to be the integral of 4 secant squared theta d theta over 16 plus, and then 25x to the 4th. 25x to the 4th would be the square of this, which would be 16 tangent squared theta. So notice it always works out like this, right? So for number 5, it was 9 minus 9 sine squared theta. For number 6, it ended up being just the secant squared theta minus 1. So I didn't actually have to factor anything out there. But it always ends up being so that if you do need to factor something out, it factors out really nicely. So this is going to end up being 4 secant squared theta, and I'm going to put the d theta off to the side now. And then I could factor out 16, and that's going to be 1 plus the, sorry, I was blanking there, tangent squared theta. It's like a car that went by and it distracted me. Squirrel. So then 4, and actually this will simplify a little bit, so let's go ahead and do that. So this will simplify to 1/4. So that's just going to be secant squared theta over 4, and then 1 plus tangent squared is equal to secant squared. Secant squared theta d theta. This time we do have a little bit left over. It's 1/4 is left over. So it's 1/4 d theta, which is just 1/4 theta. So this is 1/4 theta. Plus a constant, but we need to go ahead and plug it back in. So I like to use arrows. Sometimes if teachers are really nitpicky, they'll be like, well, technically that's not equal to that. It's just like it turns into that. It's not that it's equal necessarily. So if you ran into that on a previous test or quiz or something, just use arrows to show that one thing is leading to another thing. And that's why sometimes I'll do that. Like I'll write equals, but then if I'm like, it's like technically not equal, if you want to be really, really technical, then I'll put an arrow on it instead. Because I've had professors who've done that before. They're like, it's not technically equal, so I'm counting you off. And I'm like, seriously? So if you have a professor like that, I'm sorry. So we would want to solve for theta again, just like we did before. 4 tan theta is equal to 5x squared. So that means that tan theta would be equal to 5x squared over 4, which means that theta would be equal to the tangent inverse of 5x squared over 4. So this is going to be 1/4 tan inverse, or arctan, either way actually. You can write arctan in place of it. It's literally the same thing. Plus a constant, and then we are done with that one. Okay. So there's all of that. And we've got one more. So I'll use, kind of used more or less the 3 primary colors. So I guess I'll use either green or black or something maybe. Let's go with green, why not? Because we're kind of right in between a blue and a yellow here. So we'll do that for number 8. So let's put 8 kind of off to the side here. And yeah, nice deep forest green. Actually looks like it has a tint of blue in it. It says dark green, but it looks like it almost has a little hint of blue. Or maybe I'm just slightly color deficient. Could be. I don't know. Let me know what it is. Oh, this one is like a trig inside of a trig. Ooh, gnarly. but it is still a 9 first, so this is going to be a sine. A squared, this is in the form a squared minus x squared. So this is going to be 3 squared. And then it would be the cosine of 4x, not 2x. It's the cosine of 4x squared, which would be cosine squared 4x. All right, so then that's going to end up being a sine theta is equal to x. So a sine theta is equal to x, and our x term is the cosine of 4x. This one's a little bit more on the unusual side of things here. So we'll go ahead and take the derivative. That's going to be 3 cosine theta d theta. And then the derivative of cosine is negative sine times a chain rule, and then a dx. Ooh, getting a little gnarly here. Fortunately, we have exactly that again right here. Right there. That has everything in it. It has a negative, it has a 4, it has a sine 4x, and it has a dx. So literally it works out really nicely again. So that's going to be, let's come down here with that. That's going to be all of that. So all of that turning into 3 cosine theta d theta. And then that's over the square root of, and then that's 9 minus, and then that's going to be cosine squared 4x, which is 9 sine squared theta, just like number 5 actually. So then that is actually going to be equal to, I don't need to put an arrow. You can always put an arrow if you're not sure, but this would be exactly the same thing as this. And then this would just end up being a 3, right? So that's going to be 9, 1 minus sine squared, which is going to end up being the square root of 9, and the square root of 1 minus sine squared being cosine squared. So that all ends up canceling out completely again. And then that ends up being just the integral of 1 again with respect to theta, which is theta. So we end up with theta, and then theta goes back into what it is in terms of x. Now this one, you know what? Let's do this. Let's go like this way with it and move this up a little bit so that I have some space here. So this would be sine theta equals to cosine of 4x over 3. And then, so theta will be equal to the sine inverse of the cosine of 4x over 3. And I don't know if your professor would need you to rewrite that or not. Hopefully not. Let me know in the comments if your professor wants you to like rewrite that, because that would be a little tricky if you had to rewrite that, because it's like a sine inverse of, it's like an inverse trig of a trig. So there is a way that you could maybe write that. That would be a little bit better. But with the fact that it's being over 3, that makes it even worse. So hopefully not, but if so, just let me know. You can shoot me an email. I got my email in the comments below, as well as a link to my 5 math mistakes everyone makes and how to avoid them. That's on my website, Mars Mathematics. But yeah, just let me know if your professor is wanting you to change all that. But I'm not going to, at least for the sake of this video, because I think most people have professors that are not that terrible. So this is just going to be the integral of 1 with respect to theta, which is theta, which is the sine inverse of the cosine of 4x over 3 plus a constant. And box it in. And there we go. Actually, whoop, there we go. Now you guys can see that. All right, so awesome. That is everything. And I'm going to zoom out a little bit in case you wanted to get one big screenshot of the whole thing, I guess. So thanks for sticking it out till the end here. Hopefully you can see all that. Yeah, there we go. That way it's, and my face is not in the way either. More or less. Oh, I can zoom out a little better. Okay, yeah, so that's a little bit small, but you might be able to just crop me out at that point. So hopefully that's helpful. And I'll catch you guys in the next video. Blessings, y'all.